Hey, welcome back. So this is our session one where Pranay will be talking on TypeScript. So I think I was talking with Pranay and he told he has recently learned TypeScript and use it very much on his own project. So over to you, Pranay. So you can start with your quick introduction and then we can start jumping into the topic.
Yeah, sure. Thanks. Let me just share my screen. Uh, Hopefully my screen is visible, right? Yeah. Okay. So, hi guys, this is Pranay here. I have been working in the industry for almost 5 years now, and I started my career as a backend developer, and then made the switch to front end. And now my role I work in Tesco Bengaluru. We are basically the UK retail chain. Leading UK retail chain, and basically my job is architecting front end applications across Tesco. And I started obviously working on JavaScript initially, but recently in the past 3 to 4 months, or rather 6 months, I would say I have switched to TypeScript. And after switching to TypeScript, TypeScript has become my core language in the development workflow. So that's about me a little bit. And now let's start off with the session. And the topic that I'm going to talk about today is the importance of TypeScript in the JavaScript ecosystem. And so, I mean, not starting off a JS meetup on a negative note, but this image I have picked up from the last TypeScript, I think 2018 or 2019 TypeScript conference, where the lead speaker showed this image and basically negotiated of why TypeScript came into the picture at Microsoft. So, JavaScript, if we want to know about JavaScript, we know that we also need to know the brief history about why JavaScript was created as a language and what was the core philosophy that JavaScript tried to solve. So JavaScript, as we know it, was the first language that ran on the browser. I don't want to call HTML and CSS as languages because that's controversial, but the first language that ran on the browser, and its only role was basically being able to enable dynamic interactions on the web page, on a static web page. So your basic click handlers, basic scroll handlers, that was the only thing that JavaScript could really take care of initially, and that was the only purpose for which it was built. And if we move on, why did TypeScript come into the picture? Now JavaScript has been the front-end development space for, let's say, if it started in 1990s, or almost now 30 years. And but at Microsoft, the team realized that if they had critical code, right, and if they wanted to write type safe code, which the Microsoft developers were used to writing with their other core languages like C Sharp, they came up with the project of TypeScript. They first used it for one of their internal projects. It was not really open sourced as a standard initially. They used it as an internal project. And then, like I said, it originated from the shortcomings that they realized in the JavaScript language. I mean, like every other language, JavaScript too has its shortcomings. And I think we all know that the biggest shortcoming of JavaScript has been its dynamic type system at times, and its lack of debugging due to that. So TypeScript came out as a result of that. And the important bit that the Microsoft community did was they didn't really want to create another language that was really separate from JavaScript. They wanted to base it on the core language, which is JavaScript. So what they did was they followed the ECMAScript spec, so that they don't really go off path and create their own standards, their own conditional flows in the new language itself. So they based their new, you can say, a superset of the JavaScript language on the ES6 spec. And basing it on that proposal, what it enabled them also to do was it enabled them to introduce features of future ES6 standards, and basically it enabled them to have long-term support of the language, and it never went off path. So that was a brief history on TypeScript. And before we move on understanding the importance of TypeScript, it's also important to understand what the state of JavaScript is today in the community. Now, as we know in the industry, JavaScript adoption of JavaScript is just growing 2 years. Critical code is being written in if I'm sure, I recall reading an article where one of the NASA spacecrafts were also writing using Node.js and critical code on JavaScript. And also, I think what JavaScript has enabled is made Node.js, the runtime, as the de facto standard for your not backend servers yet, but mostly for the backend for front-end middleware servers that we have. So Node.js is slowly becoming your de facto standard for that. That means you're writing more server code. You're using resources on your backend using the JavaScript engine. And it's a logical thing to think that the more lines of code you write, the more logical thinking that you need to apply, the more cognitive overhead that you need to apply, the more words that you need to work with, the more syntax you need to work with. So obviously, like my last point here mentioned, the more lines of code means more cognitive overhead, the more you have to think about writing code. So now why TypeScript? I've spoken about why Microsoft felt it was important to introduce TypeScript. When we see when we look at the larger picture and how it fits into the community, TypeScript, uh, more critical code also comes at a cost. So you need to introduce safety in the same code base. I'm not saying that writing JavaScript code means you're writing unsafe code. That's not exactly the point. I mean, if you have small applications that you're building and that only requires basic event handling, JavaScript suffices and you don't really need to look at a type safe language. But when you have critical code, which means more business logic, more application code that you're writing, type safety and any kind of security safety is required, and TypeScript offers that. Uh, and also, the advantage of TypeScript is that it allows you to have iterative introduction. What do you mean by iterative introduction? So the best thing what I feel about TypeScript is, let's say you have legacy JavaScript applications that are already running on your servers, right? Or on your client, whatever the medium be. So TypeScript allows you to iteratively move your project or your folders or your files to TypeScript. You don't have to do a big bang change to the new TypeScript spec. You can iteratively choose files which are more critical, which are more important, which have more business logic, and just move them to the TypeScript standard. And obviously, I've spoken about this previously, but and I'll give you examples of this as how it reduces cognitive overhead, how you have to think a little less when you're writing TypeScript code. And code quality, obviously, there's no debate, and this I can tell from experience. I was also kind of against TypeScript in the last year or so, but as and when I started writing it, I realized that it improves your code quality in more ways than one. And how one basic example I can give is the data that you deal, the state that you deal with in any application is objects, and especially with JavaScript, it's always objects. And when you're transferring objects from function to function, what you're also doing is you're adding properties to that object, and one function is passing it to another function, and another function is using some parts of that. So with that, what happens is you are entering into a zone where you don't know what kind of object the method is accessing, what properties that method has. But with TypeScript and the type safety that it provides, you get an improved code quality in that aspect as well. And the last point I felt was very easier, very important because, and this is from experience, I can say that when I started working on TypeScript, um, and what it also enabled me to do was debug the backend code a little. It made my debugging skills on the backend code a little more easier. I could just look at the code and understand what's going on, which I would say if you just work in the JavaScript ecosystem, it's very difficult to understand. So that is one thing. And so this is the reason why TypeScript has become such an important thing. Moving on, like I was saying, so reduces cognitive overhead. So obviously, your intelligence, the editors have become smart. They have smarter language servers that they have installed, pre-installed inside them for each language. But with TypeScript, what you also get is out of the box documentation. So for example, the intelligence, as you can see here, it's very smart. Because the more and more code you write, obviously you need more help from the editor. Uh, so TypeScript reduces that overhead on thinking what method or what object or what property you want to access on that, and thinking what properties are available on a given object. So the TypeScript reduces that overhead of thinking for you. So, having spoken about the visible aspects or the visible advantages of TypeScript, now it's time. I think we should also speak about what the hidden advantage of TypeScript is, pun not intended. So, JavaScript uses many optimization techniques. I would rephrase it. The JavaScript doesn't use many optimizing. The engine that runs JavaScript use many optimization techniques so that your object lookups and your storage is optimized. Now, with JavaScript, you need to understand that since it's a dynamically typed language, storage and retrieval of properties of objects can be slow because it's stored in heap, right? So it's all random. So it's not like a contiguous memory that you find in Java or C Sharp, because there's no types. There's no way to identify how many bytes a property is going to take. So it's all stored randomly in the heap. So now how does JavaScript optimize property access? So let's say I create a point object and I want to access a property on the point object called y. Now when I do that, JavaScript has to go through the heap and do a hard lookup, which can take a lot of time, right? So the JavaScript engine has many optimization techniques to handle that. One of them is the hidden classes. So it's a well-known fact that hidden classes, what it does is whenever you create an object, and whenever you add properties to an object, it creates a hidden class. For every property that you add, it creates a hidden class and creates a transition from that hidden class. So here in the example that you see, if you create a point object, right? Initially, it creates a hidden class when you add the property x, and then again it creates a hidden class when you add the property property y, and so on and so forth. It adds the transition, and next time when you try to access the property x or y, it's basically order of one lookup for the engine to do, and it's optimized access. That is hidden classes. Now, there's another technique called inline caching, which the engine uses, which sits hand in hand with your hidden classes. So now what that does is, basically inline caching is based on the principle that if I'm accessing a method with a given property and with a given object and for the same properties, then the engine can just forget all the steps that it's being doing, and it can again just optimize the access and store the retrievals at one place itself. That is inline caching. So now how does TypeScript enable this, or TypeScript make this better? So now you need to understand one thing with inline classes is it depends a lot on the structure of your object. So here in this case, if I created the property X and then I created the property Y, then the transitions will be created in this order. But let's say in somewhere else in my code base, I created the same structure, but the ordering of the properties was different. Then the engine is not smart enough to know that it's the same object, because JavaScript is based on the popular term, if you know, duck typing or structural typing, right? So it has no way to know that. But when you introduce TypeScript and with its type safety or compile time type safety, what it does is it basically type boxes your property ordering. So let's say you're using point object at one place, and in another part also you're using the same object. Now, since you're using TypeScript, at compile time, the order of the properties is predetermined, and hence, and that's why I call it a hidden advantage. You would see that the engine will optimize such object accesses at compile time itself. So you will never get into a situation there where, even though the object has same structure, but if the property ordering is different, in the case of JavaScript, there will be two lookups created. In this case, there will be only one lookup created, and hence lies the optimization when it comes to using TypeScript. So moving on, I've spoken about state of JavaScript and some basic advantages of TypeScript. But let's say if I have to see the state of TypeScript, I've taken this graph from the state of JS survey itself and how TypeScript has been doing over time. The latest survey I think is not published yet, but if you see from 2016 to 2019, you can see a clear growth in the adoption of TypeScript. Yes, there has been 1 or 2% also growth in the people who've used TypeScript and felt that they're not going to use it again. I mean, I feel that is a little bit subjective based on the use cases and the applications that they've used in. But it is clear from this graph that there are a huge there is a huge percentage of people who use TypeScript and they would like to use it again. So this is a bit of a survey that so now that I've spoken so much about why TypeScript is good and why TypeScript adoption is required, now I would like to also talk briefly about if you have to start off today. Let's say you go back and think that okay, let's start off with TypeScript. How do you start off? So it's very simple. That's the best part about adopting TypeScript. So how do you configure TypeScript? First of all, like any other npm package, just install TypeScript in your project, and then you can add a tsconfig.json if you want to. So what tsconfig.json does is basically it gives options. It's like a configuration for the TypeScript compiler. So the TypeScript compiler, when it compiles your TypeScript code, it looks at the tsconfig.json to see what kind of what kind of parameters should I pass to the compiler. For example, what is going to be the output directory of uh, my destination file, and do I want to create source maps and things like that. Now this is for a basic JavaScript or a Node.js project, but obviously I think majority of us working in the front-end space are using Webpack and using it in conjunction with some of the front-end frameworks or libraries like React or Angular. So if you have to use a bundler, you can also use the TS loader, which is a TypeScript loader, as part of your Webpack build pipeline and include it as a loader to that. One thing that you also need to know is if you're using React, and obviously I think majority of us have adopted Create React app. So TypeScript supporter comes out of the box. You don't really need to do anything. You just need to provide the extension of .tsx or .ts to your files, and the bundler will take care of handling that. Now, what is a TypeScript type system? So, now coming to the little bit of details of what TypeScript is, what TypeScript actually does. So, first we need to understand the core of a type system. So, as we know, in any programming language, a TypeScript a type system is basically a rule book. You can look at it as a rule book of constraints, and basically the constraints which the compiler needs to take care of, the kind of values and the kind of operations that can be performed on variables. So now, what is the TypeScript type system? It is a statically typed system. Obviously, it is basically at compile time, it is decided what the type of the object is, and based on that, it does its storage retrievals and things like that. And also, it is structurally typed. So there are two kinds of type systems or classifications, two famous kinds of classifications for any type system. That is structurally typed or nominally typed. So nominally typed is your languages like Java. So languages like Java, where let's say you create a class of employee and you create a class of person. Now, even though an employee is also a person, you cannot really, in nominal typing, it looks at the name of the type. So in this case, person and employee are different types. But what is structural typing? Structural typing looks at the structure of the type, not at the name of the type. So that's where the nominal typing comes in. So if you look at this example that I posted here, you have two types here. One is a duck and one is a crane. Now, obviously, these are two different types with one common property. And let's say I create a crane object which has which is basically has the type of crane. Now, let's say when I do does the bird quack and I pass the crane object to it. Now, if you see here, the does bird quack method actually accepts an argument of the duck type, which is a different type. If you see the name, it's a different type altogether. But since the structure is actually similar to that crane type, it actually passes and it's all good to go. So that's how the type system of TypeScript, and that's what structural typing signifies. So this is obviously, this I think is same in any language with a couple of exceptions of, let's say, unknown and any in TypeScript. String, number, boolean, object, I don't think I need to even talk about. That's like the basic types in any programming language. But there are two things like unknown and any which are new in TypeScript. Any is basically when you don't know what the type of your variable is going to look like, use any. And if you know that it's an object, so I recommend, like, if you have objects but you don't know what the properties of that object are, use any. But let's say you know it's a primitive type, like it's a very simple type, it's not a complex type, then you can also use unknown to tell the compiler that you have no clue what the type is. That makes more sense when you look at it from a verbose perspective. And null and undefined, like JavaScript, like how in JavaScript you have null is an object, right? Same in null and undefined in TypeScript as well as subtypes of the other types. So you again, based on structural typing, they will fit into the type boxing of any of these basic types. So that was about primitive types. So now what are type aliases? So let's say I want to create a complex type, an object in my case, which has like 10 properties. And that's what type aliases are used for. You can use type aliases to create like a combination of primitive types. So in my case, you can take an example of an object here, which has like a start date property, an end date property, and a value property. And each of these properties has its own primitive types. So that's what a type alias does. It allows you to create a complex type out of primitive types. One of the basic concepts of TypeScript is interfaces. I think interfaces have a lot of different understanding in different programming language communities. But if you have to talk from a TypeScript perspective, at a very basic sense, it's just a contract. So you're just defining a contract in your code saying that, okay, this is my interface, and whenever a variable or a class is using this interface, it's going to adopt this contract. Now, the biggest confusion in the TypeScript community you'll see is what is the difference between types, which I just showed you here, and interfaces. I mean, what is the difference? You can use both hand in hand, right? So that is true, and what I suggest is whenever you have to choose between an interface and a type, you have to look at the decision where you want to see that is my type or is my type that I'm creating, is it extendable? Like, let's say if I'm creating an interface here, are these three properties, can they be extended? Can they be inherited in another type? If the answer to that is yes, then you should always go for an interface. If the answer to that is no, go for a type, which is basic, which cannot be extended. It's a basic complex type, and you can create it. You can create any type with that. But if you want to extend your type, then you can go with interfaces. Obviously, if we have types, you need a way. And since any type system, if you see, is based on your relational theory in mathematics. So in this case, if you want to combine the types, there are two ways. I mean, there are many ways, but the two basic ways that I want to talk about is obviously unions, where you can basically say can have properties which are common to both the types that are part of the union. So basically, when I say, let's say a variable has a type of t or u, so it will basically be saying that the value can have either be of type the t or u. And an intersection is basically properties combined from all the types of t and u. So there are the two complex types. So this is basically a code snippet showing you examples of both. You have a type T, you have a type U. Now, if you combine those types and assign it to a variable, you will see that I have assigned a property name here, which is on type T. But it accepts it throws you an error here, basically because it is not common. So that's the little tricky bit about unions. It kind of works a little differently. You have to think of it in a different way because it's not common to both the objects. That's a union. And let's say you have intersection. So intersection is basically, let's say I have a type T, I have a type U, and I create an intersection out of that. And then I create an object and assign that to that type. Now that works because it's basically done an AND operation. So think of it like an OR operation and an AND operation on types. So that's how this works. So if I have to move ahead. Now, these are about complex type, but I've spoken about objects already, right? So how do I represent other complex types like arrays or tuples? So it's very simple. I think this is, and if you worked with Java or C Sharp, this is very kind of similar to your generic namespacing. So here, if you see, you can create an array and provide the type in this annotation, or the other option is to just create like a type with a square parenthesis. And like you can see, I've given an example. Let's say you want to create an array of Boolean values. So you create an array with the Boolean, or you create in a similar way, and both work the same way. And tuples is basically an ordered set of values. So you can create it as like an ordered set of type one and how many other types that you want to add. And objects, as we've already spoken, it's basically your aliases. You can use aliases to create and basic object notation to create your type systems. So that was a brief intro on TypeScript and the advantages and why it's very important, and it's rather becoming important in the ecosystem. Um, yeah, that's about it. And I think not sure if we can take questions right now, but yeah, thank you
Yeah,
guys.
you can, Pranay. I think there are two questions I see, three questions. So can you go to the question tab and try to answer those?
Sure. Uh, why different hidden class are created? Why not overwrite or add new properties in the initial hidden class? So basically, like I said, so your hidden classes works on the assumption that the ordering of the properties. So if you saw my diagram there, an aspect of hidden classes is that, let me just share it again if I can. No. So an aspect of hidden classes is that the transition between properties. So let's say I create a point object, I add a property X to it. So that will create a hidden class. Now, after adding X, if I add Y, so it will create a transition from the hidden class of X to a hidden class of Y. So that's the reason, let's say if you have the ordering of the objects is different in JavaScript, then the engine creates two different hidden classes, and that's the reason that flow continues. Um, the next question is type 1 is foo string, type 2 is type 1, and bar. Sorry, I can't. But types can also be extended in a way with intersection. Yes, you're right. The types can also be extended. So when you say extended, obviously you're basically performing an AND operation, right? So that can also be done with intersection. That's a valid point, yes. But it's just that if you have to follow the nomenclature of any language, I prefer interfaces because that's like an inbuilt to other programming languages as well. So let's say, and this is from experience I'm speaking, the Java developers who look at my code base now, they find it easier to understand interfaces than to using intersections and unions. So yeah, that is one thing. Uh, Good books, resources for learning TypeScript other than official documentation. I would suggest I don't know how you pronounce it, but I refer to Alex Roshmeyer's blogs on TypeScript. That's one resource that I always refer to. And then anybody who wants to start off on TypeScript, I would suggest go look at the TypeScript conferences over the past 2 or 3 years. That's a very good starting point, actually. And yeah, that are some of the good resources. And obviously, like Udemy, I feel has a lot, but I prefer the official documentation. So I think these are the two resources that I mentioned that I would suggest to everyone. What is the advantages of JavaScript over TypeScript? So the advantage of JavaScript over TypeScript is that it is the core language. That's the biggest advantage of JavaScript. So your ECMAScript proposals or standards that come through, right? Those are going to be at the end of the day applied to the JavaScript language, not to the TypeScript language. So TypeScript, you can say, is like inherited from your JavaScript and just basically added more safety to it. But you can never discount the importance of JavaScript, and that's I can answer the next question also. Are still companies are working with JavaScript? That's very true. Even in my company, I would say like the adoption rate for TypeScript is only, I would say, 2 to 3% right now. So JavaScript is more powerful in a sense that it is easier to pick up, and obviously dynamic type languages have their own advantages. So like I said, like if you don't have the use case for using TypeScript, like if you don't require that kind of type safety in your code, if it's not that much business logic, and if you feel that there are other ways that you can handle all the advantages of TypeScript, right, like your ESLint or anything like that, so you don't really need TypeScript. But what I feel is that if you're writing a lot of critical business logic, and I think that's what's happening in the industry right now, a lot of the critical code is moving to the browser. that is business logic. And if you are transferring objects through and fro between objects, between functions and methods, I feel TypeScript is a better bet there, where it gives you the ability to predetermine the bugs or pre-catch the bugs that can arise in your JavaScript code because of its dynamicity. Uh, how inheritance is working in JavaScript? I think this is the basic thing, right? So inheritance is JavaScript is your prototype in inheritance, and same way in TypeScript as well. So that code has not changed. It's just that in JavaScript you inherit objects, or you rather create a prototype and other objects refer to that prototype. And then in TypeScript you basically inherit types. You inherit the structure of those objects. So that's, I think, the difference between the inheritance in JavaScript. And basically the inheritance in TypeScript also is the same, prototyping, but it's just that it has an additional inheritance on types that you can apply. I think that too I've answered. Thank you. I've answered all the questions, I guess.
Yeah, so there is one more, which is looks like a very general question. May I know why we are using pure JavaScript to develop large applications more than Angular in some companies?
Sorry, I didn't get that.
So so this is on more on Angular, and anybody who like to answer, they can answer also here. So this is like why companies are using pure JavaScript to develop large application than Angular.
Yeah, that is actually a good point. Um, so that is, I don't think any company is kind of relying on vanilla JavaScript these days. It's either the choice between your front end libraries of, I talk from a front end perspective, not Node.js yet, but from front end perspective, we all know that it's either React or Angular. And I think React is more popular because the learning curve in React, initially we felt that it's easier to learn, and obviously again it's written in JavaScript, so that also adds to its advantage. But what I also feel is that over time, maybe no, this is my prediction. You can say over time, I think in the next 2 years, maybe the 3 years, as and when the TypeScript adoption grows, I think the Angular adoption is also going to grow hand in hand, because I think Angular as a framework is has been underestimated. And so it's been like, I feel Angular has a lot of good things, and batteries all included, that it provides, and obviously with the type safety that it provides. So yeah, I think companies are in that phase, I guess, that building value, right? It's all about building value. Building value comes easier, obviously, with TypeScript, with the learning curve. Oh, sorry, with JavaScript, with the learning curve that it provides. But as and when companies realize, when they get into the phase that all the production applications are basically running on JavaScript, and you have bugs, and bugs which you find out only at runtime, I think the movement to TypeScript and maybe the movement to Angular will also speed up.
Okay, so we have Avas now. Avas, you want
Yeah, I wanted to
to
ask one
answer
thing.
this? Sure,
Yeah.
yeah, go ahead.
So one problem sort of I faced with TypeScript, not like problem directly, but it's more like, let's say we learn a lot of JavaScript, right? Normally as JavaScript developers, but from like in TypeScript, what I've seen is normally we learn the basic things and then jump into it, right? And then you start facing a lot of things where you feel that, okay, if I learn now this thing better, I can make it more type safe, right? And sometimes it becomes like, what do you say, you just start going into it, and then TypeScript is also adding features like sort of more often, and then you will also see like some TypeScript issues which is like going on for very long. So you are also kind of unsure that, okay, is this feature currently there or is it like going to come in. So it, I guess, like sometimes for me it feels like I'm going too deep into the type system just because I want that good type safety. So what's your experience?
Yeah, I actually agree with that. So even when I initially started working on TypeScript, right, and my team started adopting TypeScript, so many engineers in my team basically they felt that initially TypeScript feels like a very simple thing when you look at it from the outset, and you see that, okay, it's basic types. I can just assign types to my variables and it works. But as and when you start introducing it more and more, and you start using more features in your code base, you realize the same thing that I think Abbas was saying, that TypeScript is vast, and think the best what helped me, I guess, in my experience was just reading the handbook I think the TypeScript handbook that they have provided is the best out there. I feel the best resource across any type language. I feel it might be controversial, but that's my opinion. The handbook is like the best resource across any type language because they've included everything there. And I would suggest like anyone who's starting off. I mean, everyone has the different methods of learning and introducing technology, but I would always suggest that go if you're introducing TypeScript or learning TypeScript, don't just learn the basics because like Abbas said, I agree with him totally. You'll get into a kind of a rabbit hole where you don't know what's happening because TypeScript and especially with unions and intersections, that's like a very tricky concept which people realize it much later. So yeah, I agree. So the TypeScript handbook helped me a lot. And I would suggest like anyone who prefers reading documentation, right, just read the entire handbook and you'll be covered.
Makes sense. Yeah.
Okay, cool. So before ending, I think I would like to add why still larger organization using JavaScript over Angular or React, right? So that's not true. I think whatever with my experience, what I've seen, the companies either fall for Angular or React based on what their need is. So I've seen the bigger enterprises generally go with Angular, but that scenario also changing. I see a lot are adopting React. There are some who are adopting Vue.js also, but somewhere it's a mix also. So let's say you might have multiple pages, right, and you want your home screen to be load the fast, right? Just boom, you want your home screen. So you don't want any library overhead over there, right? So in those cases, people are developing with a JavaScript also. So let's say Netflix, right? So I was reading one of their blogs. So they were uh, talking about how they can make their experience super fast on their landing screen. Then they realized, okay, they have to get rid of all the frameworks, all the libraries what they're using for the first screen. So that's bang on. And the first screen is they have designed pure vanilla HTML, JavaScript, and CSS, right? So obviously JavaScript has an edge in terms of performance if you compare to the Angular or React, because finally Angular and React, it's a framework and the library overhead will be there, right? Compared to the vanilla JavaScript. But your development time, right? If you go with vanilla JavaScript compared to React or Angular, your development time will be slower. So it's a conscious call they take. So sometimes you just want to develop a backend library or a plugin kind of thing, right? So people go with a vanilla JavaScript, but let's say you want to create a very rich UI and things like that. I have not seen people go with a vanilla JavaScript in those cases. Those cases they prefer to go either via any framework or library and things like that, so that your development time will faster your so that you can deliver a lot more within a smaller span of time, right? Because a lot more thing which these frameworks and library provide, which obviously you can do in JavaScript also, but it takes your own time, and then you will have a testing involved and things like that. So that also sometimes the call versus like what you want to choose, and that's a conscious decision. I think a lot of the team or the company must be taking why to go with library frameworks versus a vanilla JavaScript. So yeah, so with that, thank you, Pranay. I think it was a very wonderful session. I saw a lot of good questions came out. I see there is one last question: why JavaScript didn't fit with Angular 2 version onwards? So, Budla Rao, I didn't understand this question. JavaScript anyway, it's a sorry, Angular is anyway is a framework on top of JavaScript, right? So it's not about JavaScript cannot fit with Angular 2. So it can definitely fit with any Angular version. As per my understanding. So cool. So Pranay, anything else you like to add, or we're good?
No, I think we are good. Thank you, guys. I think the questions are really good, and thank you. This is a good session. Thanks.
Okay, thank you very much. So we'll be jumping to our second session. We'll just take a small 2 minutes or maybe a 3 minutes break, and then we'll be just. So I'm ending this session, and then I'll be starting another session in a couple of minutes where we'll be hearing from Rahul Jain, who works for JFrog, and we'll be talking about test database using Node. It will be a very interesting topic to listen from. So see you guys on the other session. And thank you, Pranay, for your time
Thank
and
you.
effort for this session.
Thank you.